Friends, welcome to my YouTube channels. Today, new day, new problems. Again, we are coming for you for the one shear force and bending moment diagram for the simply supported beam. So here 2 point load is there and CD UDL is there, uniformly distributing load is there. So we'll solve this and we'll find the shear force diagram, shear force calculation, bending moment diagram and bending moment calculation. So this is, as you know, the simply supported beam. First we have to find the support reaction. So support reactions, once we will find, we have to calculate the two equilibrium equations. First one is summation of vertical forces will be 0. Here what we are doing, we are taking total upward force equal to total downward force we are taking. This is the concept. Total upward force equal to total downward force we are taking. So total upward force what is? You can write here RA. This will be the RB. So here AB is the beam, RA and RB will be the support reaction. RA and RB will be the support reaction. So we are writing here RA plus RB is equal to upward force RA/RB, downward force 50, then another downward force UDL. So UDL per unit length, so 10 into 4. Keep it in bracket 10 into 4. Then another load is plus 40. Plus 40. So this is the upward force. So we can see here RA plus RB is equal to 50 plus 40, 80, 50, 130. 130, no, we will check. 40 plus 50 plus 40. 130. So this is the 130 kilonewton. 130 kilonewton. Now we will take the another equilibrium equations. Moment about summation of moment about A will be take 0. So here what we are doing here, we will take the moment. So we will write here total clockwise moment is equal to total anti-clockwise moment. We will take here. So if you take moment about A, this point is fixed. So 50 is coming clockwise. Then UDL coming clockwise. 40 coming clockwise. This is RB coming anti-clockwise. So what is clockwise is coming? So we will write here 50 into 2 plus 50 into 2 clockwise. This point is fixed. Now UDL. UDL 10 into 4 load first. 10 into 4 is nothing but load. Then half distance 4 by 2. But where is this UDL? After 2 meter. So 2 plus 4 by 2. So this place you have to careful. This place you have to careful. UDL means first calculate the load. Load into perpendicular distance. Perpendicular distance means total distance. This half plus this distance. Half means 4 by 2, then this distance 2. So this much. Plus another point load is there, 40 into total distance how much? 6. Up to this 6 meter. 6. Then anti-clockwise, RB into 10. RB into 10. So if we'll calculate this, RB will come, already we calculated, RB will come 50 kilonewton. RB will come 50 kilonewton. Now you will substitute RB here, 130 minus 50, so it will come 80 kilometer, 80 kilonewton I think so. So this will be 80 kilonewton meter. This is RA, this is RB we know now. RA and RB we know now. So okay, now we'll go the shear force diagram calculation. So RA and RB will be, we know 50 and 80. So shear force diagram calculations. So what will be there here? Shear force at A. So before this we will write the sign convention. Suppose you will take here section. If we will take right side, downward force we are assuming positive. Then left side upward force is upward force will be positive. Then leftward, downward force will be negative. Here upward force will be negative. This is the sign convention for this. For us, this is the sign convention. Okay. So now we'll draw the zero shear force diagram. First we'll draw the zero shear force line. So then once we'll calculate and we'll substitute. This line we have to extend. So with reference to these lines, we will calculate we will draw the shear force diagram. So this is the projected line. Now we'll take the shear force diagram. This is called zero line of shear force diagram. In this line, whatever the shear force will come, that will be 0. Okay, we draw the zero shear force line diagram. Now shear force at point A. At point A, SA. We are assuming shear force na SA. Someone will assume to FA. So whatever, okay. SA na shear force at point A. So A na vertical force going upward. We are taking left side. This is right side, this is left side. So left side going positive. How much going RA? RA going 80 kilometer. You can write here or leave it. You can write here 80 RA and RB will be 50 kilonewtons. Okay, right? Kilonewtons. Okay. So SA is equal to 80 kilonewton positive. 80 kilonewton positive. So up to this 80 kilonewton, you can draw parallelly also. So suppose you are taking this 80 kilonewton here. 80 kilonewton at point A. Now B, A and C, no load. So it will be the horizontal line. No load na horizontal line. So okay. Now we will go at point C. SC. Now SC, if we take point load, how much is there? Downward direction. Downward direction is negative left side. So 80 minus 50 is equal to nothing but minus 30 kilonewton. So in this point, what is coming? Minus 30. No, plus only minus y. 50 minus 80 minus 30 is equal to 80 minus 50 is equal to 30 kilonewton. So if we draw here, up to this 30 kilonewton, up to this coming 30 kilonewton, 80 kilonewton. So okay, now at point, this is point C. This is point C. Now we'll take the SD. SD will take SCR. So SC, if we will take here SCL, just look here, because now here point load is there and UDL also started. So cutoff point, what will be there? SCL you are taking. SCL means just before this point. Just before this point, how much is there? 80 only. Just before this point, 80 only. So SDL will be 80 kilonewton. But SDR, once you are considering R, that means that point load also considering. So this is the 30. Now SDL again I am taking SDL. SDL means this point load will not come under this. Point load will not come under this. So what is SDL? So up to C point, what is 30 minus this UDL will come. So 10 into 440. So 30 minus 40 minus 10 kilonewton SDL. And SDR will take na. That means we will considering the point load also. So minus 10 minus 40 is equal to minus 50 kilonewton. What is this one? SDR. Then we will go the SB. SB na vertical na left side. So what is this? Positive. So minus 50 plus 50 equal to 0. So shear force at point D will be 0. So now see point C and D. What is point C and D? D will be minus 10 and minus 50. So you see here. So minus 10 first will come inclined line. We'll take the inclined line here. 32. Why inclined line? Because for point load, shear force diagram will be straight line. For UDL, shear force diagram will be inclined line. Shear force diagram will be inclined line. So this you have to. So this is the point load horizontal line. This meaning is same point load is there. Now from C to D what is there? UDL. So inclined line. Now this is called CDL. CDL, how much? Minus 10. Then what is CDR? Minus 50. CDR minus 50. So here itself, in the same point, it will come line up to this. This is coming 40, 10. This is coming SDR 50. Then SB 0. So it will draw the horizontal line here. So write this side 50. Draw the let's shorter line 0. So this is the shear force diagram at point B. So these are the H line is not the shear force line. Okay. So this will be the positive. Here will be negative shear force diagram. Shear force diagram. So all the points we know now. So 80 coming shear force at A. Then up to this no any load, so horizontal line. Then again point load up to see the 30. Again SDL, SDR. SDL means that point load will not come under this, just before this point. SDR, na, this point load is coming here. So 10 and 50. So this way we can calculate the shear force diagram. Now we'll go the maximum bending moment diagram. Bending moment diagram calculation. Okay. So bending moment at A and B. So first we will draw the line for the bending moment. 0 line will draw. So it will be easy for you when we will calculate this value, and parallelly we will draw the bending moment diagram calculations also. So we will draw this line. This line is known as bending moment line. That is called bending moment 0 line. In this point, bending moment will be 0. So bending moment at A, bending moment at B will come 0. So you can write here MA equal to 0 and also MB equal to also 0. So now we calculate MC, bending moment at C. Bending moment at C. So what will be the calculations? Here we'll take, you see here, sign convention. Here itself will take one small section. If you will take the clockwise, it will be negative. It will take anti-clockwise. This is L side, this is R side, will be the negative. If we will take the reverse, anti-clockwise, this is positive, and this is clockwise, will be the positive. This is sign conventions we are taking. Now we will take the bending moment at C. So RA into 2, 80 into 2. What is the directions going? Clockwise. Clockwise directions, left side positive. So what will take? 80 into 2 is equal to 160 kilonewton meter. Unit is kilonewton meter. So we can take SC bending moment calculation now. So 160 kilonewton meter. Now we will take the MD at point D. So look here, this 80 going clockwise, total distance is 6. So 80 into 6, then minus this 50 coming anti-clockwise, 50 coming anti-clockwise, negative. This coming negative. This is positive. So 50 into 4 minus 50 into 4. Again minus this UDL. UDL first load will be 10 into 4 is load. Then distance, half distance from D, 4 by 2. 4 by 2. This is the bending moment at D. So what is the calculations we have already? Calculations will be 80 into 6 minus. So this calculation is coming 200 kilonewton meter. This coming 200 kilonewton meter is the unit for this. So 200 kilonewton meter. Okay. So now we'll take the bending moment at E. Bending moment at E not there. No? Bending moment at B0. So now look here. Maximum bending moment also we have to calculate. So maximum bending moment where? Where will the shear force will be the 0? This will come the maximum bending moment. So these diagrams will draw here. This line. What is this line? This is the line. This and 10. So this is 30. This is, assume this distance is x. Then this distance will be total distance is 4 minus x. So this total distance is 4. I am assuming this is x. This is x. This we are assuming x. So this distance will be 4 minus x. This distance will be 4 minus x. This is 10. So how to calculate? If we'll assume this is 30. So x by 30 is equal to 4 minus x by 10. If we'll calculate here, x equal to how much will come? X by, so this we calculated x by 30, 4x minus 10. X is coming 3 meter. So if we'll calculate cross multiplication like this, 10x, then this, or you can cancel this also. 3, this 0 cancel now, 12x minus 3x. So if you calculate x equal to 3 meter. So you look here. So x equal to 12 minus 3x. So this will come 4x equal to 12. So x equal to 3 meter. So that's why we wrote here x equal to 3 meter. So okay. So x equal to 3 meter we know. So at x equal to 3 if you will calculate, we will get the maximum bending moment. So x equal to 3 once we will calculate, we will get the maximum bending moment. So maximum bending moment we will calculate M3. So what is M3 here? 80 into 3. 80 into 3, this is 3, this is 2, 80 into 5. Why 5? Because you are taking moment about 3. Or you assume this point here. This distance we got 3. So we are taking moment about this point. This point. So this height, this length is 2 plus 3, 5. Minus 50 into this 3. 50 into 3. Then minus UDL is there. So 3 meter. So 10 into 3. 10 into 3 into 3 by 2. Into 3 by 2. So this if you will calculate, it will come M3. Bending moment at 3. Or that point, if you will assume this point is E. This point is E. So you write here bending moment at E. What is bending moment at E? At point X. So this will come, how much is there? 80 into 5 minus 50 into 3 minus 10 into 3 by 2, how much coming? 205 kilonewton meter. This is coming 205 kilonewton meter. So here objective questions also they may ask na what is the maximum bending moment where the shear force diagram will be 0. In that point bending moment will be maximum. So we'll show this line here. So this shear force is equal to 0 in this point. If we'll take this line here, so this line it will come 0, 10 minus 3. So okay, so here a point is there, no? So right, we will not write because confusion. So now what is we'll draw here? Is straight line. Why straight line? Because point load. So here point load for UDL, point load for point load line will be inclined line. Bending moment UDL will be the parabola. So C to D, you see here. First here what will come? Parabola line will come. So in this point, maximum, here what will come? 205. Here this point is known as C. So bending moment at C is equal to 160 kilonewton meter. Now 205. Now what is this one? D point. What is empty? 200. But this will be also curve line only. Curve line only. This also straight line. This is parabola. This is 200. This is 200. Now bending moment at B will be 0. So draw this straight line and connect this. Disconnect the straight line, because straight line point load will be there na, inclined line, UDL will be there, parabola line, this line is curve line, this C to D is curve line. So this now Hachi, this is the bending moment diagram. And if they'll ask what is the maximum bending moment, maximum bending moment is, this is called maximum bending moment. Maximum bending moment is 205. Why? Because your shear force 0. So objective question will ask where will the bending moment be maximum? Where shear force will be 0, the bending moment will be the maximum. So this way we can calculate our point. So this point you give E point. So where the bending moment is 0, this point you give D point, this is B point. Now this point you give A point. Okay, due to the space. So this is the calculations for bending moment. So this way we can calculate the shear force and bending moment diagram for the given problems. Okay. Okay, students, watch this video. See this each and every step carefully. Subscribe the channel. Share this video to your friends so they can get the benefit. And those still not subscribe the channel. So this way we can bring for you the new video for you. Okay. Okay, students. Thank you.